Hello friends, in this video we're going to understand what XML actually is, why developers created it, and why systems still use it even after formats like JSON became popular. XML stands for Extensible Markup Language. The important word here is extensible. It means you can create your own tags to describe data in a structured way. Think about how HTML describes a web page. XML does something similar, but instead of describing visuals, it describes information itself. So instead of saying, make this text bold, XML says things like, this is a user, this is an email, or this is a product. Underneath, XML is basically a tree structure. Every opening tag becomes a node in memory, and parsers walk through that tree the same way browsers walk through HTML. This idea became extremely useful for configuration files, APIs, Office documents, Android layouts, and data exchange between completely different systems. Now let's look at what an XML document actually looks like. Alright, now look at this structure carefully. XML organizes data using tags, and every tag can contain more tags inside it. This creates a hierarchy, almost like folders, inside folders on your computer. The outer tag usually represents a larger object, and nested tags describe properties of that object. What's interesting is that computers do not see this as plain text for very long. XML parsers convert this into an internal tree structure called the DOM, short for Document Object Model. That means your program can move through the data like navigating branches in a file system. You can ask questions like find all books or give me the title inside this node. This is why XML became popular long before modern APIs existed. It gave different machines a predictable way to exchange structured information. Next, let's look at where XML still appears in real systems today. Here's the interesting part. Even if you never write XML directly, you're probably using systems powered by it every day. Android applications use XML for user interface layouts. Microsoft Word documents are internally packaged XML files. Maven build systems in Java rely heavily on XML configuration. Even SVG graphics are XML underneath. The reason is simple. XML is extremely strict and descriptive. Machines can validate it very reliably. In large enterprise systems, that matters a lot. When banks, servers, or government systems exchange data, they want structure that is predictable and self-describing. JSON became more popular for lightweight web APIs because it's smaller and easier for JavaScript to process. But XML still dominates in places where validation, schemas, and strict contracts matter. So XML is less about being modern or old. It's about reliability and structure. Now let's compare XML with JSON directly. At a high level, XML and JSON solve the same problem. They both organize structured data so programs can exchange information. But they make different trade-offs. XML is more verbose. You repeat opening and closing tags, which increases file size. JSON is smaller and easier for web applications to parse quickly. But XML has stronger document validation features. You can define exact schemas that specify which tags are allowed, what data types exist, and how the structure must behave. That made XML extremely important in enterprise computing. You can think of JSON as optimized for fast communication between applications, while XML behaves more like a formal document format with strict rules. Underneath though, both eventually become internal data structures inside memory. Arrays, objects, trees, nodes. The parser simply converts text into structures your program can navigate efficiently. Now let's wrap everything together. So in the end, XML is really about structured communication between systems. It gives computers a way to describe information in a format that is readable, organized, and easy to validate. That's why XML survived for decades. Not because it's trendy, but because reliable systems care deeply about structure and predictability. Underneath the abstraction, XML is just text that gets transformed into tree structures programs can walk through efficiently. And once you notice that pattern, you'll start seeing the same idea everywhere in computing. HTML, JSON, file systems, compilers, user interface trees, even abstract syntax trees inside programming languages. Pretty simple once you see the structure underneath. Thanks for watching, and I'll see you in the next video.